Let's get this show started. Hello, everybody. I'm John Ferguson. I own Nature's Way Resources. And I got, interested in organic gardening almost, 45 years ago. When I was in college, I studied chemistry and physics and geology and soil science. So the title of the talk, Soil Food Web, it's a new model of soil science about soil fertility management. Came out about 25 years ago. So I remember growing up, I kept hearing Billy Compton had this thing, it's far, far, far cheaper to put a $1 plant in a $10 hole than a $10 plant in a $1 hole. That is the biggest thing. As a soil scientist doing consulting work, 90% of the problems, you break rule one, you have problems. So, other things people don't realize, insect and disease control against the soil, it's better to use a little bit of a good product than lots of a bad product. I've seen that so many times create major problems. Well, what we learned in soil science, all life has to have energy. It starts with the sun. Plants, through photosynthesis, take the energy, they take carbon out of the air, form carbon compounds that we call organic matter. Then when the microbes eat it, that carbon is released. It's the same amount of energy. If you burn wood in your fireplace, the carbon in the woods combined with oxygen gives out a set amount of energy. The exact same amount of energy comes out when the microbes eat it. So this energy here, then the protozoa eat the bacteria and so forth, eventually animals, birds, and mankind. We call it a food web because the fecal material from here comes back here. In nature, nothing is wasted. It's a perfect recycling system. So what we've learned, if we get the soil biology working, we get diseases, suppression. A lot of the good microbes compete for the same nutrients. Some of them put out chemicals that inhibit the pathogens. Some of them consume the bad guys. No one's ever developed resistance to being eaten. It's 100% fatal. We get nutrient retention. Minerals in the soil become available where plants can suck them up. All these other things. And the story I love is improved crop quality, flavor, nutrients, yield. There's so much research in the last 5 years on flavonoids found in certain fruits and vegetables and herbs and how anti-cancer and stuff. Oh, I remember 20 years ago, or actually going further, back when I was in college, Gallo was considered a cheap wine to have a party with. Yeah. Then about 15 years ago, Gallo started winning awards, some of the finest wines in the world. Well, they finally admitted those were organically grown grapes. And it turns out there's a fungus that would colonize the grape root. And it's the fungus that produced the isoflavonoid that the roots would pick up that gave it the good flavor and the health benefits. So little things we've learned. Well, if we start looking at nature, you go into the desert, look at the microbes in soil, you got some bacteria, maybe a few photosynthetic algae, but that's it. But you study the grasslands, you start getting protozoa and fungus. And finally, you go to a rainforest, our most productive ecosystems, there may be 1,000 times more fungus in the soil than bacteria. So we've been able to map this. Well, we've learned that the most annual plant species we call weeds, they like soils with a lot of nitrate. What's artificial fertilizer? Nitrate-based, ammonium nitrate or something. They like soils low in oxygen. They like soils with lots of bacteria, very little fungus. So we can start looking. We look at early grasses like Bermuda, you still want 3 times more bacteria and fungus. Midgrass is almost 1-to-1, and a lot of our vegetables, equal amounts of bacteria and fungus in the soil, and so forth. Finally, the old growth forest where you might have 1,000 times. Well, we can use this. So we have to say, okay, once upon a time in nature, we had this, so what happened to it? We did things we call disturbances, maybe genetically engineered stuff. Air pollution. Remember the acid rain and the coal plants up in New England destroyed all the lakes? Fertilizers, compaction, pesticides, tillage, even organic matter. And we'll talk about later, like why does some type of mulches get rid of fire ants? Other type of mulches attract fire ants. It's all based on biology. So these things we put on the soil, we can push the system back here where it favors the weedy annual species, or we can push the system here where it favors the crops we want to grow. So to give you some examples, remember Mount St. Helens when it blew a couple of decades ago? What were the first things that came back? Annual species, weedy species. They built some organic matter, and eventually some fungus could grow in the organic matter, and then the system healed. Or after Hurricane Ike flooded the Gulf Coast. Again, the salt water killed a lot of things. It was the annual, the bacteria-loving species. So, but what we do, we can push the system where it favors weeds, or we can push the system where it favors perennial plants. So we determine other things. I love this slide because I know when I was in college, here's the book I said, you got to have sterile soil to start your seeds and stuff. And Dr. Lane Ingham, which is in Oregon State, actually did a research, measured plant growth, sterile soil, plant growth with bacteria, nematodes. And we've got millions to go. So the more healthier microbes we get in the soil, the better our plants grow. Other things, from sand to clay, this is kind of a traditional soil science thing. Blue is the amount of water in the soil. Under chemistry, the dark blue is what we have available. 67, 65% of the water is still in the soil. When we have biology, you can get to the rest of the water. Because that fungus will collect those water molecules and get it to the plant. And that's one of the reasons. Two, when plants, use turf grass as an example, when we got lots of organic matter in the soil, microbes are eating the organic matter, creating carbon dioxide. If you live in Houston very long, you know, like July and August, before sunrise, we get dead, still air. And that's when our water needs are the greatest, to the dry portion. Well, the temperature of the soil lags the air temperature. So right before sunrise, the soil is still warm from the day before, the air is cooler. So this carbon dioxide enriched air from microbes starts coming out of the soil through the earthworm tunnels or just through diffusion. And it piles up on top of grass. We might have 2 to 3 times the level of carbon dioxide because it's fractionally heavier than air in general. So until there's wind to stir it, it builds up. Sun comes over the horizon, the light hits the grass, tells, time for photosynthesis, stomata opens. The whole time the stomata is open, putting out oxygen, taking in carbon dioxide, you're losing water molecules. So if you've only had twice the carbon dioxide density, you've cut the amount of time the stomata is open or your water usage by 50%. One little effect. So some other little things we're learning. You ask about water storage. By the way, the Great Plains, historically, a lot of our forests, historically, before we screwed them up, had about 8% organic matter by weight. But if we only had 3%, 35% air, 20 water, it means we can store 120,000 gallons of water per acre. I remember a few years ago, I was brainstorming with some other people. We figured out if 20% of the lawns in Texas or Houston had used modern methods, it would reduce the floodwaters of Harvey about 40%. If only 20% of the lawns in Houston used the modern method, biological methods, so much water would have soaked into the soil, it would have lowered the floodwaters 40%. So, and like I said, a great topsoil, 8%. Other things that affect density. Just a 7% increase in soil density, 98% reduction in water infiltration. So small changes can prevent water. Well, what happens when you leave a pair of pliers, say, out in your backyard for a few weeks in the summertime, in the dew, in the rain? Rust, it locks up, right? Because rust is a chemically a salt. You've been putting the salts on your soil, locks the soil particles together, creates that infiltration problem. All for the artificial fertilizers. Well, anyway, we got other critters in the soil. Let's talk about, how about the protozoa? Cute little fellow, lives in the water films there, the amoebas and the different things, flagellates, coelacanths. Well, one of the things we've done, studying nature, we start looking at things. Bacteria, the most nitrogen-rich life form on Earth, 5 carbon atoms to 1 nitrogen. Fungi, 20 to 1. People, 30 to 1. Green leaves, 30 to 1. Protozoa, 30 to 1. Rabbits, 30 to 1. Fish, 30 to 1. Bats, 30 to 1. It's a constant we see all through nature. Researchers have gone all over the world studying soils from the Arctic to the equator, every continent. Soils that are healthy, fertile, productive, have a carbon-nitrogen ratio of 31. It's constant all through nature. We look at other stuff, brown plant material, 150, 200, deciduous wood, conifer wood. And we'll talk more about that in part 2 on dealing with mulches. So 30-to-1 is ideal. When we have clay in the soil, clay is quartz minerals, sheets of quartz. Quartz is pretty hard to test stuff. And some bacteria can put out an enzyme that breaks these plates apart, and they glue it around their body to make an armor of quartz so they won't be eaten. You created your first microaggregate soil structure. This is the Actinomycetes. This is the good bacteria that eats brown patch takeoffs in decline, and it's killed by the salts and fertilizer. Well, talking about salts, one of the things salts do, we're on the Gulf Coast. We already have a sodium problem because all the salt domes have come up. Part of our oil industry along the coast creates fault zones, groundwater gets in, dissolves it. I remember after Hurricane Ike, they measured salt up in Texarkana coming in the winds. So many of our soils are on the edge of sodium toxicity. So, well, one of the things sodium does, it fills the soil up where it can't hold good nutrients, iron, calcium, magnesium. So that's why a lot of the fertilizers wash off in the bile streams and create the dead zones. Probably too young to remember this. We used to advertise more salt as a herbicide. If finally put salts on our soils, fertilizers, or even some herbicides or chemically salts. Yeah, like I said, also there's more salt in the soil, the ability of the soil to hold water drops dramatically. Just 0.1%, and you lose about 50% of your water holding capacity. This is back in 2011. This yard was maintained conventionally. This yard went organic in January 2011. Pictures taken in September after the drought broke. The cost on the conventional side was $3,345, and they lost their yard. Cost on the organic side was $773. Which one is more effective, more cost effective? So for 30 years, I was ridiculed. Then about 10 years ago, they discovered there's species of fungus in compost or a good mulch called nematode trapping fungi. And they grow their hyphae with these loops. And they put out chemicals that mimic the root exudates, bait. So the root feeding nematode or root not nematode swims in there, they sense it, they squeeze it shut. So instead of that nematode eating your roots, it now becomes digested. And you can see starting to rupture. And the fungal hyphae turn them into plant food. Microbes are able to rip the rock apart atom by atom to get enough nutrients for the plants to grow. And there's many types of organic matter that, like people don't realize that compost, you get a yard of compost weighs about 1,300 pounds. There's 300 pounds of humates. You can either spend $400 buying humates or $70 buying a yard of compost to get the same result. Other things we're learning, in the traditional soil science, these elements are available when the soil is slightly acidic. When we get the biology working, we don't have to worry about pH as much because the microbes go out and collect the nutrients. The plant doesn't care how it gets it. Another one, tree root density. Under grass, remember the grass is a bacterial leaven. Trees are hundreds of thousands of more fungus. Look at the root density. The grass puts out chemicals to suppress tree roots. At the same time, when you put under mulch, which feeds the fungal thing characteristics. So if this is a fruit tree, which one you think is going to make bigger fruit? Survive a drought, windstorm? Yeah. So we got to think about what the plant wants biologically. For years, gardeners known about the benefits of green sand. It comes out, it has all the elements of seawater. Granite sand is rich in potassium and paramagnetic. The salt sand's got iron, magnesium, paramagnetic. One of the things we've learned is how to blend it all together to make a mineral package. But in gardening, here's a list of some of the things that trace elements do. They're so critical. This was done by two different companies maintained it. This was organic. And here the grass is maintained by a different company using chemicals. Side by side, look at the health difference. But if you want to learn more about this, let me put them all up there. Great books for the homeowner. Teaming with Microbes by Jeff Lowenfeld is about soil biology and how it works. His second book, Teaming with Fungi, excellent books. Here's the book I co-authored. There's Dr. Randall's book, if you haven't read it yet. It's a great book.